Now we'll go over some examples of the Pythagorean theorem, possibly the converse or the Pythagorean inequalities. Problems 1 through 6, you want to find the value of x and then tell whether the sides form a Pythagorean triple or not. So if you end up with a whole number for x, then the three sides would form a Pythagorean triple. Okay, on number 1, x is the hypotenuse, so you can set up 81 squared plus 108 squared is equal to x squared. You could switch these two sides around. 108 squared plus 81 squared, that's equal to x squared. So you probably need a calculator. You square 81, you add on to that 108. That's equal to, if you take the sum, 18,225. That's x squared. And then to solve this for x, you would just take the square root. So the square root of 18,225 is a whole number, first of all. 135, since it's a whole number, then these three sides do make a Pythagorean triple. Be careful about what you're given, so I would have to answer that. Yes, they form a Pythagorean triple. On number 2, you're actually given the hypotenuse and then a leg. So you really shouldn't set up 8 squared plus 4 squared equals x squared. Okay, what you could set up is x squared plus 4 squared is equal to 8 squared. So it's x squared plus 16 is equal to 64. You would subtract 16 from each side of the equation. You get x squared is equal to 48. Then x is the square root of 48. 48 is not a perfect square. We could either leave that as a simplified radical or just round it as well. If I take the square root of 48, it's going to be a little bit less than 7, so about 6.9. Since x is not a whole number, these three sides don't form a Pythagorean triple. If I were to write that in simplest radical form, what I would need to do is find a perfect square factor of 48. Yes, 4 is a perfect square factor of 48. If you factor 4 out and take the square root of that, you'd actually need to simplify more than once. The largest perfect square factor of 48 is 16. And 16 goes into 48 3 times. The square root of 16 is 4. Square root of 3 cannot be simplified. So that's the exact value, or in simplest radical form. That's still not a whole number, so these three sides don't make a Pythagorean triple. Okay, the rest of the problems for 3 through 6 are pretty similar. So I'm going to skip to number 8. Okay. For these problems, you want to verify the segments form a triangle, and then is the triangle acute, right, or obtuse? So first, to verify that the three sides make a triangle, we actually have to use the triangle inequality theorem. Is 90 plus 216 more than 234? That should be fairly obvious, yes. You can check the other side lengths as well, but 216 plus 234 definitely have to be greater than 90. 90 plus 234 is definitely greater than 216. But that's verifying the sides make a triangle. And then we could determine the type of triangle it is by comparing c squared. So in this case, c has to be 234. That's along the side. Comparing c squared to a squared and b squared. I could have made 90b and then 216a. It actually doesn't matter, but I'm going to compare 234 squared. I'm going to leave this blank right now. I don't know if it's equal to. It could be less than. It could be greater than. But 90 squared plus 216 squared. So you probably need your calculator like I'm using right now. 234 squared is 54,756. Again, I'm comparing that to 90 squared, 8,100, plus 216 squared, 46,656. And then so I'll add that to 8,100 and then compare that to 54,756. They're actually equal. You know what kind of triangle it is? It's a right triangle since they're equal. If c squared is greater than a squared plus b squared, it would be an obtuse triangle. If it's less than, then it would be an acute triangle.